Okay, so here's the job we just poured. There are a lot of different types of curb and gutter, so one thing to keep in mind, this is just one of them. So here in LA, this is referred to as type C integral curb and gutter. So that is your gutter, which is here, and your curb. They're all tied together, poured at the same time, which is referred to as a monolithic pour. So here you go. So if you'll see here, you can see the pattern. This is a rotary finish. And the reason this is a rotary finish is because the incline of the street is greater than 6%. So here in LA, anytime you have a surface that is more than 6% and it's concrete, you have to do what's called a rotary finish. Let me try and sort of get a closer look so you can see it. And it's swirls that are made with a wood float so that you get more traction. It's a lot rougher than, say, this part, which is referred to as the shiner. So let me sort of go through the technical details of this. So here you have your curb, and this is the street. So it's going to be hard to tell here on this video, but from here, the crown of the street, this is an existing street, so we have to widen the street as part of this project. So we have to put 10 new feet of street on. So this is the crown of the street. So you may not be able to tell, but this is the highest point right here, the middle of the street. So from here to the edge of the gutter is a 2% minimum downslope. That's for water. You want to make sure that if any water or any liquid goes down the street, it goes off to the side. Then from here, this is the type C gutter. So here's the construction of this. From here to here, which is referred to as the flow line, there's a 6% slope. So this is 2 feet from here to here, and this is 1.5 inches higher than this. So the water flows that way. Then as you'll notice here, I was saying that we put a rotary finish on anything 6% or greater. Well, here's what's referred to as a shiner, a 4-inch shiner. And this is the flow line. So the shiner is the smooth part. So this, you can see it all up and down it. That part is smooth because the design is such that the city wants water to be able to flow freely. So this slope pushes it to the flow line, and then the flow line allows the water to flow. That, all the water from here comes from here. So that's sort of the science behind a street. And this is the crown. A lot of people have never really noticed it. You haven't paid attention to it, but if you're going to be a contractor, even if you're not going to do road work, this is something very important to know, because a lot of times you'll have houses or buildings that are in flood prone areas or where there's a lot of rain. So it's going to be important at some point for you to know and understand the street near that property. And if it's flat, the street is flat, you'll be able to tell, because when it rains, there'll be parts of the gutter that just hold water, even when it's not raining. So they may sit there for days and days. So something just to be aware of. So again, crown in the street, 2% minimum, and our 2% minimum is 1/4 inch per foot. That will push the water this way. It will then flow down the gutter, which is a 6% slope, to our flow line, to our shiner, and into the flow line. So the flow line is the very corner, the edge right there. And then the shiner, again, that's the smooth part that allows the water to run. Now also, on the top of the curb, it's really rough, because again, if people are stepping out of a vehicle or you park on the side of the street, they don't want it to be slick. You don't want to have a slick surface, and smooth concrete creates a slick surface. So that's why they want to keep only a 4-inch gutter, so that's enough room to allow the water to flow. Now, another thing to pay attention to, don't know if you can see it, but this, both the curb and the gutter actually slope slightly that way. So here to here and here to here, they're sloping back just a little bit. And I can tell you how much it's sloping back, and that is 1/8 of an inch per inch. So for every 8 inches this is a 6-inch curb, but if this was an 8-inch curb, from this point to the top of it, it would lean back 1 inch. So for every inch you go up, it's 1/8 of an inch backwards. That's what's referred to as the batter. It's the same thing for here along the edge of the gutter. It leans back 1/8 of an inch per inch. The reason is because if cars drive on here, which they often do, tires hit, if it's straight up or if it's leaning back that way, it'll chip the edge of this off and it can do serious damage to car tires and rims. So this way, when you have a batter that's just a slight lean, if a car rolls up here, the tires will slide down there. Now, we're obviously gonna fill this in. In this case, we're gonna use concrete asphalt, but whether you use asphalt or whatever it is, but typically for asphalt, this is why it was designed that way. You have big roller machines that as they lay the asphalt, the roller machines compact it. Well, they used to have it set up so that there was no batter here, and that's B-A-T-T-E-R, batter. There was no batter, which is that lean, right? And what happened is you would have these machines, and as the edge of them would hit this, it would just chip the hell out of them. So you would have these streets that had gutters that were just chipped all along it. And then that would end up creating problems down the road because you wouldn't have a tight water seal. So the engineers redesigned it so there's a slight batter on this. So as the asphalt fills up and the machine comes, the very edge of the tire doesn't hit this because it's leaned back just a little bit and allows them to compact it. So that's a quick lesson on curb and gutter. Now, again, there are a lot of different types of curb and gutter, but this is one of them and it's very important. Now, the one last thing I'll show you is here is where we're gonna put in the driveway. The driveway is gonna go here, but along the flow line, which again, the flow line is right against the edge here, you'll notice this is the driveway. So this is where it comes down. Cars will drive in here, but we have a 3/4 inch lip here, and that's so that water won't flow up onto the driveway apron when it's completed. So you'll always have water flowing the least path of resistance away from the building. And again, water, it's always designed, there's a watershed design by engineers in the city in such a way that they want it to flow away from the house. This is a tough project because it's on a hill. So as you'll see, the yard goes down. We're not gonna backfill all of it. So there's a completely different setup we have to do in the yard, but the city wants anything within a foot right along the edge of the curb to slope away at a 2%. You'll hear me talking about 2% a lot because that's sort of the water flow standard. And 2% is also referred to as a 1/4 inch per foot. So every 4 feet, you'll have a 1 inch drop. This is a little steeper, it's 6 inches, 6%. But typically when you hear about drains, pipes, anything where water has to flow, a lot of times you'll hear the 1/4 inch per foot. And that's sort of the standard that's used a lot because that's a good slope in order to provide flow for water. Same thing here, you'll see the drains we've got. We're gonna backfill these. This is for the downspouts. They're gonna drop into these drains and go into what's called an LID box, which is, I'll talk about that on another video. But again, 1/4 inch per foot. So 1/4 inch per foot starts from back there and we go all the way around here. So, you know, if you're going long distances, 100 feet, 200 feet, you always want to maintain 1/4 inch per foot. So again, if you're at a 1/4 inch per foot and you're going, say, 100 feet, that means every 4 feet, an inch. So you have to drop 25 inches, 2 feet and 1 inch over the course of 100 feet in order to make the water shed properly. So this, another reason we can't pour the street and the curb and gutter at the same time. One, the city doesn't allow it. they want it to be two separate pours so that the two aren't tied together. We'll have what's called a cold joint there. And then if there are ever any issues with the street, or they need to take out a piece of the street, it doesn't ruin the gutter. You don't have to cut into the gutter, and vice versa. Another advantage to doing that is, you'll see here, this is compacted base on the ground. So all of this, we dug the old street out. We brought in new base material, what they call CMB, crushed miscellaneous base. We compacted this to 95%. So it's 95% of the original compaction. This is, you'll see a lot, there's a sort of a lot of loose gravel on top now, but we're gonna scrape this off, spray it, and then it'll be ready to pour here. So it's, if I could get a stick, I'll show you, but you'll see the advantage is now, because we have our slope set up, the crown is there, we've already set our 2%. That's where we poured that. Now we don't have to form anything else. We can just come in and we pour right there. This is our form for the curb and gutter side. This is our form for the street. So we'll just come, we'll pour, and then this entire thing is already set up. So that's nice, that makes it easy. The one last thing I want to show you here is how hard this is. I don't even know if I can show you. So I've got wooden stake. We have to use metal stakes to form, because when you do your wooden stakes, you can use them here and there, but for the most part you can't, because as you'll see, the wooden stakes can't even really go in. It starts to destroy the stakes. This is damn near as hard as concrete itself. And so if you try and hammer in a bunch of wooden stakes, they're not going to hold your forms very well. So metal stakes are typically what you have to use. If you do find yourself in a bind where you have to use wooden stakes in order to form, make sure you have like a rotary hammer so that you can drill holes first and then put the stakes in before you set your forms up. But metal stakes are what all the inspectors are going to want to see. And it's what you should do anyway, because it's just going to make your life a lot easier. So quick review: crown of the street is the highest point. Drop 2% minimum. It can be more, but 2% minimum to the gutter. You got to do a rotary finish on the gutter. Anything more than 6%. That goes for streets, driveways, anything that's concrete in the city. If it's more than 6% of a grade, then you have to rotary finish it so that you get traction. An exception right here along the flow line, which is this corner here where the water flows. It's a 4-inch shiner, which is standard. Again, that allows the water to flow freely. You have a batter of 1/8 of an inch per inch. So for every inch, let's just call it 8 inches. If you have an 8-inch high curb, it should be raked back like that 1 inch. Again, this is a 6-inch curb, so our batter is 3/4 of an inch. If it was 2 inches higher, it would be 1 inch. That allows for car tires and rims to slip off of this without damage if they hit it. Same thing here. The inspector's going to want to see that. Oh, one last thing. We put 6 inches, so we graded this entire thing. We dug everything out below it down for about 14 inches. We have to put back a minimum of 6 inches of road base. So we did 6 inches, just over 6 inches of road base. Now, also for this type curb and gutter, again, if you're in LA and you're going to take the test, it's type C. They want a minimum of 6 inches here. So anywhere along here, this curb, this gutter, this street has to be a minimum of 6 inches. Then the curb on top of it, in this case, has to be 6 inches. So if this is perfectly flat, if your base is perfectly flat, you're probably going to end up with the edge of the gutter being 7.5 inches. And then down here, which is referred to as your B, as in Bravo, that is your B variable, which is the flow line. There has to be a minimum of 6 inches between the flow line and the road base. So again, if this is flat, let's assume this is flat. In order for you to have 1.5 inches between here, and this having to be a minimum of 6 inches, you're gonna end up with 7.5 inches here minimum, 6 inches here, right at that corner minimum, and then you're gonna have a 6-inch curb. All right, so for those of you taking the test, general engineering test, that is a rundown on integral C-type curb and gutter for the city of Los Angeles. Even if you're not in Los Angeles, but you're in another municipality, in another state, in another city, wherever, all these principles are the same. So your city will have very similar, if not the same, requirements for curb and gutter. So take it for what it's worth. Look at whatever your city, your municipality is, see what minor changes, tweaks they may have, but this is really good for anywhere. Okay, so here is the finished product. Now it's been dry for about 2 weeks now, so people have started parking on it, so you can see it's a little bit dirty. But this is it done now. This other half of the road looks like complete hell. That's because the city's gonna come at a later day and replace that, in a later date, shall I say. The reason they required us to rip out this section of road and replace it is because we are building this house, and anytime you do an upgrade or build a new house, the city wants to figure out a way it can get something out of it. So this road was too narrow for emergency vehicles to make it up this street, and it's really narrow over here. So it was less than 20 feet wide. The city wanted to make sure that there was at least 20 feet across for emergency vehicles to get up. So this section was about 7 feet wide. So we widened it to 10 feet. Plus we have 2 feet for curb and gutter. And that's why they do it. So that's another thing, depending on where you are, access is big for emergency vehicles, ambulances, fire trucks, police vehicles, that sort of thing. So in your municipality, they may want the same thing, which is to widen the street in order to get emergency vehicles up there if you do a project. So that's the finished product. If we were gonna do this other half, it would be done the exact same way we did that one. We could have done it at the same time, but weren't required to, so we didn't, because it's very expensive to build streets. But yeah, once they replace it, it's gonna look the same over here. It's gonna be concrete asphalt is what they refer to it as, which is really concrete, which is different than like asphalt blacktop. But yeah, that's that.